Good morning, everyone. Today we're going to continue our discussion on using Excel in order to model time value of money. Let's have a quick review of what we discussed last time. We learned about the compounding process where to compound means to increase. So it's getting the future value given either a single cash flow or an annuity. So whether it's an annuity or it's a whether it's an annuity or it's a single cash flow, you can get the future value. The reverse process is called discounting, where you're given the future value, a single cash flow, and you'd like to get its present value. So it's computing for the present value. So we said that in Excel you can make use of the FV function here. Okay, so we learned about the syntax of the FV function, and we learned about the importance of considering the direction of the cash flow because Excel is very particular about that. So when we compute for money items, we normally, if we're getting the future value or the present value or the annuity PMT, we if you don't want to if you're just interested in getting the absolute value, what we do is put a negative sign, okay, and put net positive values here, especially for the present value or the future value or the PMT. Okay. Now, uh, also, when we're computing uh, for the n, the number of years, the number of periods, or the interest, you do not put you do not put any negative here. Okay, so last time we were tempted to put a negative sign there just to make the answer positive. Okay, there's no such thing as negative rate or a negative n per. Okay, we always we don't put the negative here. However, we just want to make sure that you have to take into consideration the direction of the cash flow. So if you're given the future value and the present value, one of them has to be negative because you cannot have both positive or both negative cash flows. One of them has to be an outflow and the other has to be an inflow. It doesn't matter what the outflow or the inflow is. It can be your present value or your future value or your PMT. Sorry. Now, just one more thing before we before we leave before we go to the next session. Now, suppose you have this cash flow, okay? This is time zero. This is one. Suppose you have an initial investment of just to simplify the example. Okay, let's see. Let's make it 4 and let's make it 5. Okay. And then you have an ordinary annuity here of 50. Okay. So you have an initial single cash flow here, single amount, and then an annuity of 50. And then you're asked for the future value. What is the equivalent future value of this amount, of this stream of cash flows? Now, recall last time, either we only have a single amount or an annuity. Okay, we did not have an example where we have both single amount and annuity. So for this one, okay, let me close this. Let's say, how do you compute now for the FV, for the future value? So if you recall, FV, okay, and let me put a negative here so that the answer will be positive. The rate is, let's say it's the same as, okay, let's just make it 10%, and then comma. The n per, the number of periods is, so this is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Sorry, this is 6. Okay. So n per, I'll just type it here. Usually, I don't advise you typing, hard coding the numbers there. It's best when you're using functions to represent a particular amount in a cell in Excel. The advantage of doing that is if you're going to change the parameter, you don't have to go to the formula and change this. Okay, you just have to go to the to where you placed your, let's say, NPER. Just change that, and automatically this formula. Let's do that class. Sorry. Okay, so I'll just put here rate. Okay, let's say 10%. NPER. NPER. Here we know it's 6 years. Then we have future value. We have the present value at 100. And you have also the PMT annuity of 50. Okay. All right. So we can now compute for the future value is equal to future value. And notice that all are saved in cells. So I'll not, you don't, it's not good to type 10% here. You have to link it to your cell. The advantage, as I said, is you can easily change this and automatically your formula will change. So good practice, do not put absolute figures in your function, in your formula. So n per is 6 there, comma. So we have an annuity here. Annuity is 50, comma. And we also have a present value, 100. So we're inputting here the two present values. Type is at the beginning of the period, so we can put there 1. Sorry, not at the beginning, at the end of the period. End of the period class. So this is the beginning. At the end of the beginning, you have your annuity. So this is annuity ordinary. Okay. All right. So control enter. Okay. So okay, I forgot to put the negative here. Negative sign. All right. So 562.94. So the present value of 100 and the 50 have the same have the same direction. Both of them are all investments. Okay. So at the end of the 6th year, you'll have 562.94. Okay, I'll pause for a while and allow you to take your notes and do this formula. Okay, let me just copy this. Okay. All right. I'll give you a few seconds to copy the model. If you're done, class, kindly please chat yes so that we may continue. Okay, let's wait for the others. Thank you, Aliana. Okay, Johan, thank you. Okay, Ales, thank you. Sami, Sophia, Nix, Jashan. Okay, so good. Thank you so much for your feedback. So let's continue our discussion. Okay. Now, sometimes, okay, so could you kindly delete this first? Delete this. Okay, I think I gave you the solution to this PV. So let me also Okay, let me clear all the drawings. Okay, so let's take a look at this cash flow. Now, sometimes what you're asked is to compute for the, let's say, in this case, either the both the present value and the future value of each of the cash flows. And then you're also asked for the net present value and the IRR. So this problem requires us to fill this up, okay, and fill this up and the total, get the total, and then get the net present value and the yield of this investment. Okay, so first question. You have an investment of 9,000 today, and the returns of the investment is you'll get a cash flow of 1,000 next year, 2,000 after 2 years, 3,000 after 3 years, 4 years, and 5 years. Now, my first question is, is this investment sound? Okay. Is the sum of your uh, inflows greater than your outflows? So I'd like you to chat in the chat box. Okay. Maybe chat it to me first, direct message to me so the others don't see your answer. Tell me if it's okay or not, and what's your reason for that. Okay, I'll give you a minute to do that, class. Just a basic question, a basic finance question, which all finance students should know and should be able to answer correctly. Please direct your answer to me personally so that the others will not see your answer. Okay, thank you, Nix. All right, good. So Nix has an answer. The question is, these are cash flows. The negative here indicates that it's an outflow. You're going to invest 9,000. Then the positives here, this is your time frame. After 1 year, you get 1,000. After 5 years, you get 5,000. So the question is this a good and sound investment? So yes or no, and tell me the reason why. Okay, Aliana, thank you. Alice, thank you. Sophia, please write why. Okay, Sami, Aliana, Johan, Nix, okay. Okay, Joshan, thank you. Sophia, kindly uh, give the reason why that is your answer. Sophia, are you there? Okay, good. Thank you. All right. So all of you have the same answer? Yes. Okay, good. Yes. Okay. All right. Let me give my comment. I'm glad that you answered that because that means that uh, this concept has not really sunk in to you. Okay, as finance students, we should be very aware that 9,000 compared to this is 12, um, 9, 12, and 3, 15,000. So it's a question of 15,000 versus 9,000. Okay, and that's what all of you, okay, all of you answered, which is good. Okay, it's good, class. However, it's not accurate. It's wrong. Okay, take note that you cannot add these cash flows. 1,000 after 1 year, 2,000 after 2 years, 3,000 after 3 years, etc., cannot be added, class, because they don't belong to the same time frame. Remember, class, that there is such a thing as the time value of money. So you can't just add these cash flows. Okay? So what do we have to do? We have to put them all in the same time frame. And then that's the time we can add the cash flows. So if I let me illustrate that. So if I have this, okay, so this is our cash flow, class, right? So this is 0 up to 5. Okay. You have here negative 9,000. For the first year, you have 1,000, positive 1, positive 2, positive 3, until positive 5. On the fifth year, positive 5. Okay? So this is 1, 2, etc. up to 5. Now what what you're doing now is just add negative 9, 1, 2, 3, 4, 5, which is totally wrong. You cannot add cash flows that belong to different time frames. So what do you have to do? You have to convert. Either you discount. So how much is 1,000 after 1 year? How much is it now? So you're actually getting the present value of 1 after 1 year. How much is 2,000 after 2 years now? Okay. How much is 3,000, 4,000, 5,000? How much is 5,000 after 5 years? How much is it now? So once you have converted them in, let's say, time 0, which is the present value, then that's the time you're able to add these cash flows because they're already at the same time frame. Okay. So this is a very concept of the time value of money. Okay, money has cost. You cannot add these cash flows. Okay. All right. Let me pause for a while. May I ask you to please chat if that's clear? Okay, so please, if there's anything that we should really learn, okay, we should really be conscious about, is adding cash flows like this. Okay, it's violative of the time value of money. Can you please chat in the chat box, please? If that concept is clear, good, good. So next time you're given a problem like this, or given a a question like this, I hope you will not just add the cash flows. Okay, so let's proceed to do what we have to do. I'll clear the drawings. Okay, so it's either we convert all of this into its present value, or we convert everything into its future value. Okay, so let me see first. Okay, now, do you have this, class? If you go here to the name box, you call this the name box. Do you have WACC and WACC1? Kindly chat, please. Do you have it? This is the name box, class. And then if you click this, do you have WACC and WACC1? Okay, I'll teach you what that means. Okay, do you know what that means, class? What's the implication of having a WCC here or a WCC1? Have you used the name box before, class? Again, may I have your response? Yes or no, please? So that I know. Okay, good, good. I appreciate those answers because this is an opportunity for us to learn new things, especially in Excel. Yeah, good. All right, that's good. That's great. So before anything else, uh, okay. All right, let's please go to Control F3. Please press Control F3 for for Mac. It's Command F3, and you'll have this name manager. or or you can go here, Home, where's the name manager, or Formulas. I think Formulas here, class. Formulas, and then this one in the defined names. Okay, formulas and then defined names, and then go to name manager here. So that's the same as control F3 or command F3. Now you can see here, okay, you can see here several items. Do we have the same thing, class? Do you have the same thing? Okay, yeah. Most probably because I shared this file with you. Now I want us to delete this first. Okay. So we'll discuss what this means. Okay. So let's okay highlight everything and then delete. Are you sure you want to delete the selected names? Okay. Okay. There you go. So delete everything so that we start from a blank slate. Okay. So once you have deleted everything, okay, again, I'd like you to chat now if you have deleted everything and there's nothing appears there. Okay, good. Okay, good. All right. Okay, so let's start. Let's discuss the importance of named ranges. Okay. So here we're going to use the rate 10%, and this is the weighted average cost of capital. I'm sure you have finished your financial management, and that one of the topics discussed there is the weighted average cost of capital. So it's the what we call the hurdle rate, the minimum rate by which an investment has uh, has to be earned in order for any project or any capital budgeting project to be feasible. Okay. So we're going to make use of the weighted average cost of capital at 10% as our rate. Okay, so the objective is to determine the determine the uh, present value first. Okay, so we use a function is equal to FV so that the sign will be maintained. Use negative FV. Okay, the rate is 10%. Okay, comma N per. What's the N per for the first cash flow class? What will be the N per for the first cash flow? Okay. Okay, correct. It's zero. Yeah, correct. It's zero because this is the cash flow at time zero. Okay, right, zero, and then comma. PMT, we don't have an annuity. This is not an annuity, comma. This is the present value, right? Present value is this one. And then type we ignore because this is not an annuity. So close. Okay, so enter, control enter. So the present value of 9,000 today is of course 9,000 also. So we were able to maintain the sign. It's still negative 9,000. Now the problem is we cannot just drag this. Okay, why? What happened to this one? When we copied the formula down, it became negative FB. The rate became C54. It went down also. B56 is correct because this is now the NPER for the second cash flow. And C56 is also correct, okay, because this is now the next cash flow. So B56 and C56 are okay, okay, because when we copy down, this these amounts also go down. The problem is this one, okay? So we have to resolve this class. So how do we change this class? How do we address this? Because we don't want to write the formula again in the second cell. We want just one formula and then copy it down. That's what we call efficiency in Excel. We don't want to be writing formulas where we will have to keep on writing the same formula over and over again to different cells. If we can create one formula and copy that to anywhere we want, then that will be a good formula. All right. Thank you, Aliana. Okay, Aliana suggests it's C53. Yeah, correct. C53. Function F4 for C53. That's good. Okay, but we have some choices here. Okay, so let's discuss this. So I go here. Now, there's such a thing as relative cell reference. Okay, relative cell reference, let me write it, class. Relative and absolute. So for example, C54. So this this position, class, C54, it's relative as far as column C is concerned, and relative as far as row 54 is concerned. So that's what we call relative cell references. Now, what we can do is to fix column C by attaching a dollar to it. So this one is $C54. So this is absolute. We call this absolute because column C is fixed, and this is relative because row 54 remains to be not fixed. So when I copy this formula, column C remains the same. Anywhere I go, anywhere I copy it. But row 54 will change. And then we also have C $54. Okay. Wherever the dollar is attached to, then that position is fixed. Okay. And also, lastly, $C $4. So in this cell address, okay, both the column and the row is fixed. So this is an absolute cell reference because both of them are fixed. Okay, this one is totally relative. This is relative with respect to column. This is relative with respect to the column. So with the row, 54. And this one is relative with respect to the column. So the question is, which among these four do we use here? So is it, I'm sorry, it's 53. Sorry, class, this is C53. So is it $C $53? Or we know that C53 is wrong, okay? Or is it $C53 or C $53? So what's the answer, class? The first one, okay? All right. All right. So Nix is suggesting that it should be row 53 and not C because we are copying vertically. Okay. Very good answers. Okay, let me clear the drawings again. Okay, so there are two choices that will give us the same answer. Number one, we can change the address of this by pressing F4 there. You notice now it's changing the cell positions. $C $53, C $53, and $C53 and C53. So this one is wrong. F4. Now let's try this, class. $C $53. So what will happen if we fix both the columns and the rows? If we copy this formula, class, with $C $53, column C and row 53 will not move. It will stay there, affixed. Okay, enter, and then I copy this down. Okay, so if I go here, class, our formula is our rate is still here. Okay, the end per is B60 and the cash flow is C60. So that's correct. Okay, so the first one is correct. We can fix this. We can fix both. However, there are instances when it's not good to fix, to make it absolute if it's not needed. Okay, there will be instances when it's better not to fix it, not to fix something which need not fix, which we don't need to fix. Okay, take the case of this one. As Nick's pointed out, we're going to copy the formula down, right? We're going to go down. Now, notice that we are not changing columns. Okay, when I copy down, it's still column D. When I copy down, it's still column D, column D, column D. But we're changing the rows. Okay, so here in this formula, what needs to be fixed is the row, so that the row position does not change, but not necessarily the column. Okay, if we were going to copy this formula and copy it along along the row and the column, then we need to fix both. Okay, because if we're going to copy the formula in such a way that the column position is changing, then we need to fix the column. But in this case, we're going to copy it down. Therefore, we're only going to fix not the column, because the column position of the formula will not change. So only the row. Okay. So we have shown that this is correct. $C, $53. But let's see that scenario when, okay, we only fix the, here class. We're only fixing the row. C, $53. Okay. So let's see what happens. The last answer is 8052.55. Okay. Enter, control enter, and then copy down. There you go. So let's check the formula. We're still here. This is still 10%. Okay. B60 and C60. So, okay, modeling wise class, modeling wise, do not just fix everything absolutely. Okay. If there's no need to fix a particular position, either the column or the row, then do not do that. Okay. Only fix what needs to be fixed. Okay. So let me pause for a while and and ask for your feedback if that's clear. Okay, good. Okay, great. Thank you. All right. Okay, thank you. All right. So that's one way. There's another way. Okay. And this is more advantageous. Okay. So this one, now, this is 10%, and it's your weighted average cost of capital. Okay. So what you can do is two things. Number one, give this a name. By giving this a name, we can make use of this not only in this worksheet, but also in other worksheets. So how do we give a particular cell a name? Notice that the name of this cell is C53 here. This is the name box. That's the name of this cell. But we can change the name if we want. Okay. So two ways to do this. Number one, use this name box. Okay. So instead of C53 here, okay, I can put a name there. Now take note, I cannot use A1. Okay, because A1 is already a name of a cell. So you can put names here and make the names reasonable and easy to remember. Do not put a name that has 20 letters. Make it simple and make it really logical. So here I'm going to name it WAC. Okay, so I'm going to type here weighted, capitalize it, WAC. There. Okay. All right. Then enter. Okay. I press enter. Okay, wait. Sorry, where am I? Yeah, there, class. And if I click this, see, my WAC is now existing. Now let's see, class. Again, I'm going to, let's delete this again. Let's delete this. And then this is equal to negative FD. Okay. Now the rate. Now, suppose you don't know where the cell is for the rate. That's no problem because I can just type W. Okay. And if I type W, what appears here are many functions that start with W. including the name that we created there. There's the swap and then tab there. So you now represented your C53, your $53. This time it's $C $53, but with a name. Okay, and this is a lot better because you know that this WAC represents one thing as compared to $53 or C53, which is quite let's say too generic. This one, you know that this is represented by WAC, and you know what WAC is. Okay, so comma, enter is this one, comma, PMT, skip, and then future value. Okay. Close, enter, and then that WAC acts as a $C $53. It's an absolute reference. There you go. If I go here, it's still WAC. Okay. Or there's another way to name this cell. Okay. You can write, you can put the name of the cell close to the close to the cell itself. So you notice that I placed WAC beside 10%. So how do I do that? Okay. What I do is I highlight the name and the value. Okay. And then going here from defined names, right? I can click create from selection, or the shortcut is Control Shift F3. For Mac, I think it's Command Shift F3. Okay. So we can do it two ways. First, highlight the name and the value. You have to put the name beside, either above, to the right, to the left, okay, but not diagonal. Okay, it has to be beside, below, above, to the left, or to the right. Okay, here, and then Control Shift F3. There you go. Now Excel guesses correctly where the name is. Okay, so create names from the values in Excel correctly guesses that it's in the left column. Okay. All right. Then if you press OK, then since we have done that already, we have already given it a name. Okay, so let's do this. Let's once again delete first this one. So how do you delete a name? Go once again to Name Manager here. So we have here the WAC. The value is 10%, and it refers to this particular cell, $C $53. And take a look at this. I'll discuss this. The scope is workbook. What do you mean by scope is workbook? Take note, it's not worksheet. The scope is workbook means anywhere you go. Okay, let's do that first. Okay. So for example, I go to anywhere class. You go to multiple IRRs. Okay, you go there. And then let's say in this cell, you need the value of WAC. Okay, so I can type is equal to WAC class. And you notice that that appears there. Is equal to WAC, Control Enter. I'm able to get it. It's 10%, right? So that's what it means to be able to access the value of that name anywhere. Okay. Now question. Can I create another value here, let's say 12%, and also name it as WAC? Can I do that? I already have the object, the name WAC, right? Can I, in this worksheet, okay, all right, thank you, Jashan. Okay, no, all right, actually you can, class. You can. So let's do this, class. Let's give this also, let's give this 12% another name, a name WAC. Let's see what happens. So how do we go there, class? Formulas. And then once again, let's use this. Create from selection or Control Shift F3 there. And Excel guesses that it's the left column, right? So, okay. All right. So we now have two WACs, class. Okay. If I go here, I have WAC, but only one WAC. But take a look at your name manager. Okay, now we have a problem. We have two WACs here, 12% and 10%. Okay, the initial one was 10%, and the scope is workbook. The second one, also WAC, is 12%. However, the scope is only in multiple IRRs. What does that mean? If I'm going to use WAC in this worksheet, multiple IRRs, the WAC will be your 12%. Elsewhere, workbook class for all the others. Okay, if I go here, say NPV IRR worksheet, and if I access WAC, it will be this WAC, the 10%. Why? Because the scope of this is the workbook. What about the other WAC? The WAC in multiple IRRs worksheet, which is 12%, will only be for that worksheet. So if I, okay, so let me close this. If I write is equal to WAC here, okay, now you have two WACs. So what do you want? Do you want the WAC for the workbook or the WAC for this specific worksheet? Okay, down. I'll use WAC for this particular worksheet. Tab, Control Enter. Then I have 12%. However, if I use the WAC for the workbook, this one, tab. So this is for for this workbook, financial modeling. Control Enter. Okay. All right. What happened here? Enter. There's a typo in my case. Let me. Is equal to WAC. Okay. Oops. What do you notice, class? Does it appear, class? WAC again. Can I use this one? Workbook. What do you see, class? Can we use the WAC for the workbook? Chat, please. Okay. Yes, the answer is no. You cannot. Because the WAC here for this particular worksheet will only be 0.12. Okay, so you can do that. But why will you do that? There are so many other names that you can use. Okay, except for maybe if you just need for this worksheet to give that WAC a name, then it's okay. It really depends on your purpose and what you want. Okay, so all right. So name manager. Okay, so you now have two WACs. So let me just delete this 12%. It will not. I will not get confused with that. Okay, so this is how you delete, class, the name. Okay, all right. Any questions so far? Are we clear, class? With using named ranges. Are we clear with named ranges? Okay, you can also, by the way, you can also, okay, good. Let's say you have this, just for example, okay? Just for example, class. Okay, let's say this one, class. This one. You have a range of names here and a range of values. So if you're going to name this one by one, for example, 10%, I'm going to type here rate, here, NPER, here, PV, then here, 50. That will be quite unwieldy, especially if you have so many, let's say, variables and their values. So what you can do is just highlight this and then Control Shift F3. Sorry, again, cancel, highlight, Control Shift F3. So we have a case here where you have several names and the values. Okay, I'm going to give a name to the rate 10%, NPER 6, PV 100, PMT 50. Okay, again, Excel guesses, it's in the left column. Okay. All right. Now, if I check this has now a name, rate. This has now a name, PMT. If I check the name manager, okay, there you go. Okay, you have the name, you have the values, and then you have the cell position refers to, and then this is for the workbook. Okay, you can name several values at the same time. Just position it in such a way that it's beside the value. That's why, class, when I do when I do modeling and worksheets, I would usually dedicate the first portion here to be my to write my variables and their values, especially if they're constants. Okay, I would put it here so that this one I will give names to my to my values, especially for those that are absolute or fixed. Okay, so that's a very good practice, so that you don't have to keep referring to that particular cell reference. Now, what if you forgot? What if you already have several names and you forgot the name? Can you still access it? Plus, can you still access it? So it's equal to negative FB and then the rate. Let's say you forgot, oh, it's what's the name? So do you have to do it alphabetically? Is it letter A? No, it's not A. Is it B? No, it's not B. Is it C? Until finally you reach W. That will be a waste of time, class. There's a shortcut for that. Okay. What do you think did I press? What did I press, class? Because I pressed something and all the names that I've used in this workbook appeared. Okay, so this is for, in case you forgot the name that you gave the variable that you need. Okay, let me repeat, class. Cancel this. Okay, you forgot the name of rate. Okay, no problem. Don't have to go through the alphabet A, B, C, W. Okay, you have an answer here. Function F3, so it depends on your workbook. Okay, if you need to type function for your F3, then type function F3. But for others, it will just be F3. So in my case, it will be F3 because my keyboards for F1, F2, F3 are separate. Okay, F3. So kindly check, and then you have the page names there. So just choose back. Okay, and there you go. All right. So let's again. Okay. May I have your comments, class? Confirmation if you're able to follow up to that point, class, the F3. So check your keyboard. Okay, good. Great. All right. Thank you so much. Okay, so let's now finish this. What? Emperor is 0, comma. Oh, sorry. Emperor is 0, comma. No annuity. And okay, C55. And then, okay, sorry. It's not an annuity, so ignore this. Okay. Control Enter. And then copy down. All right. So this is what I was telling you about, class. So you now have your present values. They're now all at time 0. So can we now add this? So let's put here total. So not this, class. We can total this. This one we can. Alt equal to. Okay, it's a sum. Okay. Alt equal to. Control Enter. There you go. 12,421.95. Okay, I think I did not. Oh, yeah. 9,000. Oops. My mistake, class. Sorry. This should be PV class because we're getting the present value. Okay, sorry about that. I was surprised because the values increased. When you get the present value, your value will decrease. Class. Control Enter. Okay, 9,000 will still be 9,000. The present value of 9,000 now is still 9,000. Okay, now take a look at this. So this is now a valid metric. When you add all the present values, then you're not violating any principle of finance as far as uh, adding cash flows. And there's a special name for this. It's called your net present value. So this one, net present value. Okay, I'll give you 1 minute class. How about, okay, don't use this, okay, because you can actually just get the future value of this one. Okay, you can get the future value of this because this is already present value. You can project it to 5 years or 4 years, etc. Okay, I want you to make use of this one. Assume that we have not computed this. How do you now get the future value based on these cash flows? Okay, I want you to one formula again, copy down, and I want you to chat in the chat box what you get for year number 5. Okay, so I'll give you 1 minute for that. Just one formula, class. One formula. Okay, thank you for your answers. And your answers were, I think you were in unison that FV, and then the rate is WAC, and then N per is 0, and the value, the not PMT, but the present value is this one. Okay, type ignore because this is not an annuity. Control Enter. All right. So this was your answer. All right. So first things first, class. If you have 9,000 now, how much will it be after 5 years at 10%? Will it still be 9,000? Okay. Will your 9,000 now be 9,000 after 5 years? Okay, kindly chat in the chat box, please, if it's yes or no. What do you think? I have 9,000 now. Okay. Whether this is an inflow or an outflow. Will the 9,000 be after 5 years? 9,000. Please chat yes or no. Okay. All right. Okay. Yeah, you're correct. It's no, class. Of course, class, it will increase because you're compounding, right? When you're getting the future value, you're compounding, you're adding amounts to that based on the interest rate. So this is wrong. Okay. How can 9,000 be still 9,000 after 5 years? Okay, so I'll give you another chance. Okay, please try one more time and give me the formula for the future value here. Take note that this is the cash flow at year 0. So how many periods have lapsed? Okay, when you're getting the future value in 5 years' time. Okay, so think about that first. Okay. Okay, Alice, would you mind sharing your screen and telling us what you did? I'll stop share.
Sure po. Hold
Okay.
on, I'll just share screen now.
Okay, thank you, Sammy. Okay, let's see what Sammy did. Can you, yeah, there.
Okay. So,
So go first to the E55, please. Can you increase the size? Yeah, there. Okay, so that others can see. All right, good.
okay,
Press
so
F2, please, F2.
F2. F2.
Yes.
Oh,
There. Okay, there. Okay, that's right. Okay. So, titingnan natin kung tama ito ba. All right. So what did you get, Sammy?
I got 14,494.59.
Okay, so once again let's go to your F2, your formula. So your WAC is okay. What is your what is your NPER?
I placed 5 because you said after 5 years, and then
Correct.
I held that constant for
You
all.
fixed
Yeah,
that. Fine.
yes, sir.
Okay. And then C55, that's okay. All right. Then let's go to the next one. Your E56. F2 again.
Okay.
F2 again. Okay, take a look at this formula class. So you have your WAC. Sorry. However, here, your time your time frame is still B60. So does that mean that the cash flow occurring at year one will still be compounded for 5 years?
Oh, sir, I think it's 4 years.
Yes, correct. So it's no longer it's no longer 5 years.
Yes, sir.
So we can fix it at B60. Okay, Sammy, let's go back to the E55. So let's discuss your work there. Okay, F2 again, please. F2. Okay, how do we modify this class? Let's take a look at Sammy's work. How do we modify this class? So that when we copy this formula down, the year should be, for year 0, it should be 5 years. Because from year 0 to year 5, those are 5 years of compounding. But when we go to year 1, there should only be 4 years. When we go to year 2, there should only be 3 years. Okay, because from year 2 to year 5, there will be only three periods. And then when we go to year 5, there should be 0 years, right? 0 years of compounding. So that 5,000, the future value of 5,000 should also be 5,000. Because that 5,000 there is already on year 5. Okay? So how much is the future value of cash flow on year 5? How much is its future value on year 5? So it should be also 5,000, right? Okay, so
Mhm.
let's do this. Sammy, go to $60. At the end of that, okay, why don't you subtract minus what? B55.
Yes, sir.
Okay, so minus B55. Okay, there. Now take a look at this formula class. It's $60 minus B55. So what will happen is the B55, B60 will be fixed. So it will be always 5. And then
Mhm.
when you go down, so the first one will be minus B55, that's minus 0. So that's
Mhm.
5 years. When you copy this down, it will be minus B56. B56 is 1, right? So 5 minus 1, that will be 4 years, etc., 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 until you reach until you reach B60, where you have 5 minus 5. So that's 0 and per. Okay? So could you press Control Enter, please? Sammy, Control Enter. What did you press, Sammy? What did you press a while ago? F2, please. F2.
Okay. F2.
F2. Press F2 first. F2. There. What did you press? So if you press, what did you press? Enter, right?
Enter. Yes,
Okay,
sir.
press Enter. Press Enter, please. Okay. Now, when Sammy pressed Enter there, what happened? It went to the next row. So go back, Sammy, to the E55. I'm showing here some shortcuts. Okay,
Mhm.
F2 again, F2, please. So that's the formula that Sammy created. Now, where do you want your active cell to be? Do you want it to be in E55 or in E56? Class, where do you want your active cell to be? Is it E55 or E56? The answer is you want it to be in E55. Why? Because you want your active cell to remain there so that you can copy down. Because if you press enter, your active cell will go down, okay? And then you will have to go up again to copy, right? See? See the logic there? So again, press F2. Instead of pressing enter, press Control Enter, or in Mac Command Enter, so that your active cell remains there. Okay, so you don't have to. It does not go down, so it's still there, and then you can just copy down, please. Copy down some there. Okay, take note, class. The future value of 5,000, which is after 5 years, its future value is still 5,000, right? Because it's already the fifth year, and you're getting the future value on the fifth year. Okay, thank you, Sammy. Thank you. Great. So let me once again share my screen. Okay, so let me repeat this, class. Is equal to, we're getting the future value. Now, we have to make use of this time frame. Okay, the rate is, we can use WAC. Okay, what happened to my WAC? Let me type W. WAC, comma, N per. As I said, the N per for the first cash flow, the number of periods, this is occurring at year 0. And we're getting the future value at year 5. So there should be 5 periods there. So I can use this 5, the last period, and then fix it. $60, but I have to subtract this. Okay. That way, class, our N per becomes variable. It keeps on decreasing because we're subtracting 5 minus 0, 5 minus 1, 5 minus 2 as we go down. Okay. PMT, ignore. This is not an annuity. Cash flow is 9,000 there. Okay. So here, again, class, you press Control Enter and not Enter if you want your active cell to still be in the same cell. We want it to be in the same cell because we're going to copy the formula down. Okay, so Control Enter. That's why I'm able to maintain my active cell in the same cell. Okay, and then copy this down. All right, so check this, F2. So WAC is correct. 5 minus 5, 0. That's correct because on year 5, the period between year 5 and year 5 is 0. Okay, and then C60 there. So this is 5,000. And can we now add this cash flows, class? Please chat. Yes or no, class? Can we add now the cash flows in the FB column? Can we add these cash flows? Answer is yes. Okay, we can now add them. Correct. Why? Because they all now belong to the same time frame. This is year 5. All of them are now year 5. So I'll just copy this. Okay. So what's the conclusion, class? The conclusion is that if you add all your cash flows, inflows and outflows, and they're positive, then the investment is sound. Okay. So our first answer was wrong because we added this one. Okay. And it turned out to be 6,000. That's wrong because that violates the time value of money. So we either, okay, convert them all to present values or convert them all to future values. In fact, convert them all to any time frame. Whether you can convert them to the 3rd year, to the 4th year, but why do that, class? So either you convert them to year 0 or to the end of the period. And let me just check. This is the present value, right? If I get the future value of this, okay, let's see. Let's convert this amount, which is the present value. Okay, this is year 0. How much will this be in 5 years' time? Let's see. I'm going to put here negative FB. Then try it, class. And then we have your WAC, comma, N per is, this is the value now. how much will this be in 5 years, comma. So not a PMT, it's a single cash flow 1652. Ignore the type, control enter. So there you go. It's the same class. It's the same. So 2661.51, which means that we have the correct answers here. Okay, either you got the future value of these items here, cash flows, projected into the future value, get the sum. This is your net future value. This is your net present value. All right, so we can now get this formula. The present value of your cash inflows, okay, will be the present value of your positive inflows, which is this one, right? So if we sum this, sum of all, take note, sum of the present value of your cash inflows. Cash inflows, which means positive, this one. Okay? On the other hand, what's the present value of your cash outflows? There's only one cash outflow, this one, right? Okay? So this is the present value of your cash inflows. This is the present value of your cash outflows. Can we add them? Yes, class. They're all present values. So out equal to G60, okay, sum of G59 oops, and G60. Let me just write. Okay, we're adding those two cash flows, G59, G60, control enter. There you go. And that's your present value of your cash inflows. So the decision rule, class, is that the decision rule is if your NPV, net present value, which is, sorry, this is not, okay, I put this here. Your net present value is this one, class. It's the present value, okay? This is your net future value. Net future value, net present value, 1652.59. This is 1652.59. This is your NPV. And what's the decision rule? Project, this investment is feasible. Okay? The project is feasible on what basis? On the basis of NPV. Okay, on the basis of NPV, which is positive. All right. So let me pause for a while and allow you to copy or do your worksheet. And then I'd like to ask you if this is clear so far. Okay, good. Thank you. Wait for your classmates. So one. Okay, good. I think everybody is clear on this. So last thing, okay, there's a there's a function in Excel called NPV. Okay, so let's do that is equal to NPV. And before you type open parenthesis, okay, Excel gives us some information about this function. Okay, so take note that the NPV function of Excel returns the net present value of an investment based on a discount rate. So we have your WACC, discount rate, and a series of future payments, including negative values and income positive values. Okay, So it's getting the present value. So which is what we did here, class. Based on a discount rate and a series of future payments, both negative and positive values. Okay, so if you try to run this class, okay, what's your rate? Your rate is WAC, right? Comma, what are your values? Your values are your positive and negative inflows. So highlight this class, highlight this, and tell me if you're getting 1652.59. Value 1, value 2. Okay, do not use this class because this is already processed. Okay, you have to use the original data. This one. Okay, did you get 1652.59? All right, so we have some answers here. No. What did you get? Not not 1652.59. Okay. All right. So everybody is in agreement that you got. I'm checking if I post recording. I might have post recording a while ago. All right. You got 1502.35. Let me evaluate that. Is equal to NPV class. And you have your WAC. And then comma. Our cash flows. Okay, take note, not your present values, but your original cash flows. And true enough class, 1502.35, which is wrong. Okay. So what do you think, what made this wrong? What made this wrong class? So let's write again the formula F2. And I'm going to, okay, once again, let's read carefully what Excel requires when you use the NPV function. What do you think? Where do you think did we go wrong there? Returns the net present value. Okay, so this is what this function does. Give the net present value of an investment based on a discount rate. We have the discount rate 10%, and a series of future payments, negative, and income positive. So both negative and positive. So where did we go wrong there? Any comment, class? Any comment? Yes. Sami, kindly share your comment with everyone. Okay. Future payments. Okay. So this is where Excel is actually wrong. Okay. Excel gets the net present value only of the future payments and excludes the present value. Okay. Because this cash flow includes the 9,000. So in the syntax of Excel, okay, WAC, the values there is future payment. So this, it only includes from 1,000 to 5,000, right? It only includes 1 to 5. Otherwise, if we include 9,000, it will read this 9,000 as occurring after one on the first year also. So it will change. It will change the timeline. Okay. If we include 9,000, it will treat it as if it occurred on the first year, this one on the second year. So all in all, there will be now 6 years. Okay. If we get this class, okay, what do we have here? We're actually getting the present values of all these cash flows, which in our case is the present value of our cash inflows. This one, 10652.59 is the present value of your from year 1 to year 5. Okay, so this is now your present value of your cash inflows because from year 1 to year 5 are all inflows. So how do we adjust this? we have to include, okay, the present value at time zero, because that cash flow, the present value at time zero, is part of your NPV. Okay, that's the correct interpretation or meaning of net present value. It includes all cash flows, okay, not only future, it includes even the year zero. So we will just, okay, we will not add, we will not subtract because it's already negative. We will add, okay? So we will add that 9,000. It's already negative. If we subtract that, then it will become positive. Okay, let's see, class, what you get. And please comment if you got the right answer, please. All right, good, good. All right, good. Okay, so very good, class. We're able to get the NPV function. Okay, control enter, and we get 1652.59. Okay, now in in capital budgeting, okay, there are two major major, let's say, metrics by which we we determine whether a project is feasible or not. You're done with financial management, right? Fin management. Kindly please chat. I'm sure you're done with that because it's either first or second year. Are you done with financial management? Okay, good. Okay, thank you. And did you learn the concept of IRR, class? Please chat in the chat box. If you learned IRR and then comma, how you computed IRR? Was it manual? What did you do in order to compute IRR? IRR manual. Wow. Manual. So how about the others, class? Manual, manual. Okay. When I teach financial management, I uh, I don't we don't use manual. We use rather Excel. So sa classroom Excel kami. Okay? So sa exam, nagbibigay ako ng another portion na capital budgeting. It should be it should be practice driven. Okay? Because actually nobody uses manual in the real world. Okay? So here, that's why it's good we have an elective called FINMODE financial modeling, because we will learn those things that you did not get to experience in your uh, financial management here in FinMode. So this is very easy, IRR there. Okay, so this is returns, the internal rate of return for a series of cash flows. So this is where Microsoft Excel is correct. Okay, series of cash flows. Okay, so comma, values. We now include year zero. Okay, and guess, we will discuss that in the future, but notice it's in brackets, class. What do we mean by if a parameter is in brackets? Remember, class? What does that mean? Yes, thank you, Nix. You're correct. It's optional. For now, we don't need that. Okay, and control enter. Okay, the internal rate of return is 15.47. Okay, question. Based on NPV, is the project feasible? Yes or yes, class? We have discussed that. Based on NPV, is the project feasible? Yes or yes? Of course, you know the answer. It's yes, class, because the NPV is positive. If the NPV is greater than zero, then the project is okay. If the NPV is negative, then reject the project. Now, based on IRR, is the project okay? What do you think, class? Based on IRR, is the project feasible? What did you learn in your financial management? Uh, please chat your answer and then why. But also include the reason why It's a yes or it's a no. I want to see your reason for that. If the answer is yes, why? If your answer is no, why? Okay. Thank you, Nix. How about the others, please? Waiting for the others to give their answer. Okay. Thank you, Sophia. So I want to see the answers of four more students. Okay. If you're not sure, you may just guess. It's okay to guess. The question is, based on the IRR, is this project feasible? Yes or no? And what's the reason? Okay, thank you, Aliana. Okay, so three more, class. I'm waiting for the answers of three more. Okay. Jason. Uh, okay. Okay. I saw some answers. Okay, the answer, class, is that this is feasible because you will have to compare this with what we call the hurdle rate. So this is what we call the hurdle rate, the WACC, hurdle rate. It's just like a competition, just like steeple, what do you call that? When you're doing a sprint, and then you have to run over a, I forgot the 110 hurdle race. Okay, so the hurdle rate or the WACC is 10%. So the project, class, will be will be evaluated based on this hurdle rate. The project, any project whose IRR is greater than the hurdle rate is acceptable. Okay. Now, what if there's a conflict between your NPV and IRR? Suppose the NPV says yes because it's positive, but the IRR, let's for example, this is 9.5%. The IRR says no, reject the project. Okay. So once again, let me ask you, the NPV is 1652, so it's okay. The IRR is 9.5%, so it's a no. So what will be our decision? Type accept or reject and give me your reason. Okay, once again, please answer. Yield IRR is 9%, 9.5%. NPV is 1652. So should we push through with the project or not? Why? Accept or reject? Okay, thank you, Sami. How about the others, please? I want to see your answers. Okay, if IRR is 9.5%, okay, it's lower than the hurdle rate. NPV is 1652. It's positive. So should we accept the project or reject it? Please state your reason why you're going to accept or reject. Okay, thank you, Johan. Thank you, Sophia. Okay, I think two more students. You may guess, just guess. What do you think? What's the most logical answer for you? Who hasn't answered yet? Reject. Okay, accept, reject. All right. Okay. So thank you for your answers, class. The answer is that when the NPV and the IRR okay, uh, conflicts, for example, NPV says okay because it's positive, IRR says no because it's less than the hurdle rate. What will prevail is always the NPV. Okay. When there's a conflict between NPV and IRR, the NPV always prevails. For what reason, class? Because in the way the NPVs and IRRs are computed. Okay. In computing for the IRR, there's a certain assumption, okay? There's a certain assumption that makes the IRR computation less robust. Okay, because in computing for the IRR, as I said, okay, we perhaps we'll go into that and show you how IRR is computed. We'll show that quote unquote manually in Excel. Okay, and you will see why NPV is the superior, quote unquote, superior method as compared to IRR. Okay, but of course, if both reject, then no problem. We only have that benchmark when there's a conflict between the two. Okay. All right. I hope that's clear. Just to recapitulate, okay, when you have an uneven, let's say, uneven stream of cash flows, and you're asked whether this project is feasible or not, you don't add the cash flows. Okay. What you do is either get the present values or future values. The answer will be the same whether you get the present value or the future values. So when you get the present values and then add all of them, the amount is called your net present value. Okay. When you add your future values, the amount is also called the net future value. Okay. If the net present value is okay, then automatically the net future value will be okay. Okay, because you also derive your net future value from the net present value. So they will always be in consonance. If the net present value is negative, then of course the net future value will also be negative. Okay, then we learned how to compute for the net present value using Excel formula, Excel function. Okay, so take note of the future cash flows. So we had to adjust this. Okay, just use the future cash flows and then add back. We're adding back in this case because our first initial outflow is already negative. Okay, and then we use IRR, and then we said that if NPV is greater than 0, is positive, then the project is okay. If IRR is greater than the hurdle rate, then the project is okay. If there is conflict between the two, then you choose NPV. Okay. All right, now this one, okay, we have time for this. Okay. We have now non-annual compounding periods. So we have 1 million now, and we have an annual rate of 10%. This is your WACC, let's say. Okay, so we can just make this our WACC also. Okay, so we can use the WACC above there, here, the 10%. Let's use that to make the computation simpler. And then this is an investment for 30 years. Okay, now we're given this set of compounding. So it's either we compound annually, so that means you're only computing your interest once a year. So semi-annual, you're computing it 2 times a year. Quarterly, 4 times, bi-monthly 6 times, monthly 12 times, bi-weekly is 26 times, weekly is 52, and daily compounding 365. And we have infinite compounding, which we call continuous compounding or a perpetuity. Now, I want you to use one formula here, copy it down, And then, okay, here we're going to use a different formula. Up to here, class. Copy down your formula, okay, to get the future value. And then after that, we will compute for the effective annual rate. Why is that so? Because if we will compute twice a year, okay, so effectively, you are earning actually more than 10% per year. If you're computing the interest 365 days a year, then the effective annual rate will actually be more than 10%. Okay, because that 10%, when you're given a rate, it's always annual. So you compute it only once a year. Okay, so for this one class, for this one, we know that the rate here will be 10%. We know that the rate here will be greater than 10%. This will be greater also than, this will be greater than 10% annual compounding, or even greater than semi-annual compounding. Because class, as you increase the number of compounding, so this is called non-annual compounding, as you increase the number of compounding per year, your future value will be greater, okay? And your effective rate will be greater, okay? So let's first start here, class. I want you to tell me one formula here, class. One formula, okay? Maybe we can, okay, let's first do this. Let's go to formulas and then go to name manager. Okay, and then let's remove this. And per, okay, let's just maintain the WAC. Delete. We don't need those names. So what do we need to fix here? We have already here the WAC. Okay. We can fix the 1 million because this will not change, and also the years. Okay. So okay, we can make this as let's just use rate. Okay, class. Let's just use rate. And this one, okay, we can use years. Okay, so we can highlight this. Then if you recall, Control Shift F3 or create from selection. I'll use Control Shift F3. And then the names are in the left column. It's good. It's correct. Okay. All right. So this one, it's now called your present value. Take note that automatically Excel inserted an underscore because a name has to only be one, cannot be let's say two different words, just one word. Okay, here, Excel automatically inserted underscore. This one is your rate. This one is your years. Okay, so give me a formula, class, except for the infinite because that will have a different formula. Okay, I'll give you 1 minute, please. Give me the formula for the first one and then copy down. Okay, so let's first get the future value. We know that this will be negative FB. Okay, first is our rate. Our rate is 10%, but that rate, 10%, is an annual rate. So if we have semi-annual, it means the rate will be computed twice. It will not be 10% every time because that will make it 20% for the whole year. So 10% rate, okay, for annual, that's 10%. But for semi-annual, it should be 5%, 5%. So you have to divide this by the number of compounding, number of periods per year. Okay, so for annual, it's 10% divided by 1, so that's 10%. For semi-annual, it's 10% divided by 2, that's 5%. So every time the interest is computed, it's 5%, okay? And then another 5%. For quarterly, it's 2.5, 2.5, 2.5. So we have to divide the rate by the number of compounding per year, okay? Daily, that's 365. 10% divided by 365, comma. Now, the number of periods, class. The number of periods is 30 years, okay? 30 years. So if it's annual, okay, it will be 30 years, 30 periods. But if it's semi-annual, so how many times a year are you going to compound? 2 times a year. So in 30 years, that will be 30 times 2, okay? So for the number of years, you have to multiply the number of periods because, okay, there will be more compounding if it's non-annual compounding. So years, then you have to multiply this on the other hand with the periods per year. Okay. So if it's annual, no problem. Years times 1, that's 30 times 1. However, for semi-annual, it will be the number of years, 30 years, times 2. So there will be 60 compounding periods. Okay. For quarterly, there will be 240 because 30 years, sorry, 120, I mean. For semi-annual, it's 60. Yeah. 30 years times 2 periods per year. For quarterly, 30 years times 4 periods per year. So you have to do that, class. Comma. This is not a PMT. Ignore. Our present value is fixed at 1 million. Okay? That's the present value. And then type ignore because this is not an annuity. Okay? Control Enter. Okay, let me increase this. Okay. So for the first year, for annual compounding, it's 17.45. If I go down, okay, notice, class, that all of these are 20 years, 30 years. But those that have more than one compounding per year will have, of course, the higher future value because you keep on increasing your interest rate. You earn interest rate on interest on interest on interest. Okay, so naturally you'll have the higher FV. Okay, then let's go here. How about the rate, class? What will now be the effective annual rate? Okay, so 17 million, 17.45 million, that's how your money will grow in 30 years time from 1 million at 10%. Okay, so the rate here, of course, will be 10% because that's the rate. However, for this one, it will not be 10%. Of course, the effective rate will be higher because the future value here is higher. So let's use the rate function is equal to rate. Okay, rate. So what's our N per? What's the number of periods, class? What's the number of periods? So will it be 30? Okay, let's see, class. And then comma, PMT, comma, what's our present value? This is our present value, comma, what's our future value? Now take note, your future value should be negative, class. Negative. Or your present value should be negative and your future value should be positive because the direction of the flow should be different, opposite. Otherwise, you'll have a wrong answer. Okay, so ignore the type, ignore the guess, close, control enter. So this is 10%, class. We expected that. And then if you go here down, okay, even if we increase the, sorry. So you can see that the effective annual rate for those with non-annual compounding will be greater, of course. Of course, because they have a higher future value. Okay? This one. All right. Then for the formula here, okay, I gave the formula here. The effective annual return is equal to 1 plus the nominal rate divided by the periods per year raised to the periods per year. So here, class. The effective annual return will be 1 plus the nominal rate. This is the nominal rate, class, divided by the periods per year. So what will be the periods per year? That's column B. Okay, so you're actually getting the rate per period and then raised it to the periods per year. Okay, so in the interest of time, let's do this, is equal to 1 plus the nominal rate is 10%, then divide it by the periods per year. So what will happen now is that you're getting the periods, the rate per period. So 10% divided by 2, that's 5%, but you will have to raise it to the periods per year. There. Control Enter. Okay. Then, of course, this includes the principal. So you'll have to deduct -1. You have to exclude the principal. Okay, wait. Let me increase. Okay, let me formula text. So there's a formula class. Okay, and then copy down. Okay, you can see that it's the same. Okay, exactly the same. Using the rate function, using the formula 1 plus the nominal rate divided by the periods per year, then raise it to the periods per year, and then -1. Okay, so just fix that. Okay, and then you have also in Excel, you can make use of the effect. This is very easy, effect. There. So it returns the effective annual interest rate. Okay, what's the nominal rate? 10%, comma. What is the number of periods per year? This one. Very easy, class. Control Enter. And let's just make it in percentage. And same 3 decimal places. And then go down here. One more. Okay. It's equal to formula text. There. Okay, so I have your formula here for E72. E72. And this is for F72. Okay, so what did we learn here, class? If you have more than one compounding per year, your future value will, of course, be higher because you will compute the interest more than once a year. Okay, so what will happen? You'll have a higher future value, and therefore you'll have a higher effective annual rate. That's EAR. Now, question, class. What will be the infinite here? Okay, I gave you the formula here, so that let's do this so that we finish this already. Okay, if it's continuous compounding, so that's in perpetuity. Okay, infinite compounding. The formula is PV times E to the R times T. Okay, so let's compute this is equal to, you have your PV, okay, times E. So that's your exponential E to the R. Okay, what's R? R is your rate. What's your time? 30 years. Control Enter. Okay, and of course we expect that if it's continuous perpetuity, then it should be higher. Okay. Daily is only once per day. Infinite is infinite compounding. Okay. And for this one class, okay, you cannot use the formula. You cannot use this rate function class. Okay, years. Here we can use this one. Okay, present value, and the problem here is negative. So years. Okay. There. We can use this one. Okay, but not this one. Okay, because we cannot specify what's the periods per year. Okay. How about this one class? Can we use this? We cannot also. Okay. We cannot use the effect function because it will require us to determine the periods per year. And we cannot identify in infinite, we cannot identify the, but there's a formula for this one class. Okay, so, and I want you to find out what is the formula for the interest effective rate class if it's infinite compounding or perpetuity. Okay, so I'm sorry I extended on time. Now, next meeting, we'll do this. NPV also unequal lives. I hope were able to get maybe 1.5 sessions more in order to complete this, and then we go to the next topic. Okay. Yeah, let me stop recording.